Welcome to another Rock and More production. This is a math video, and it is about identifying three-dimensional shapes. Three objectives for our 3D identifying lesson. The first one, you will be able to explain the following terms in your own words: face, vertex, and edge. Number two, you will be able to count the number of faces, vertices, that's the plural of vertex, vertices and edges a three-dimensional figure has, and you will be able to identify the following three-dimensional or 3D shapes: cubes, prisms, and pyramids. And there are different kinds of these, so we'll be talking more about that later. So, starting with the first objective, faces. The faces of a three-dimensional figure are also known as the sides. You can see here I've highlighted a face in green. The rest of this figure is blue. This is just one of its faces. Another way to think about it is that they outline the surfaces of a polygon. Um, the faces on this figure are squares. How many faces can you count on this figure? Pause the video right now and count all the faces of this figure. So this cube or this figure has 6 faces, and we can mark them here. I'll mark them with an X, and you have to, it's a little bit hard because they intersect each other, but we'll call the top that one, or better yet, I'll just number them. So we'll call the top the first one. We'll call the bottom number 2. Let's call the back 3, and this is a hard one because those are those are kind of overlapping. We'll call the front face 4, and if you think about the front, that's the one that's outlined here, and the back was this one that's outlined here. So we're at 4. Then I've got this side as 5, and then this last face that I highlighted green is 6. So this particular figure has 6 faces. All right, let's move on to an edge. An edge is a line segment where 2 faces intersect. So I've got one highlighted here in green. So we've got this top side, or this top face is intersecting with this front face, and it's making an edge right here. So right now, I want you to pause the video again, and I want you to try to answer this question. How many edges does this cube have? So pause the video, count them up. All right, so let's count them. A little easier to label. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges that this particular figure has, this cube. Now our last bit of vocabulary here is vertex. A vertex is a point where edges intersect. That's what a vertex is. So you can see we've got 3 edges that are intersecting here. That one, that one, and that one. And where they come together, that's a vertex. Now you might hear somebody use the word vertices. That means more than one vertex. It's the plural. So you've probably predicted that I'm going to ask you this question. How many vertices, again, that's the plural of vertex, how many vertices does this cube have? So pause the video and try to figure that out. Well, let's label them. 1, 2, 3, 4, 5, 6, 7, 8. So this cube has 8 vertices. So I just went over 3 new words, 3 vocabulary words that are really important when we're talking about 3D shapes or 3D objects. I recommend that you rewind and watch that part of the video again, just so that you get double the amount of information. You want to double your chances to understand those terms. And now that you've reviewed, there's one more term that I want to talk about, and it's congruent. Just to quickly review, congruent means the same or equal. And if I have this basketball here, and I have it make another one, if they're exactly the same, then we call them congruent. These two basketballs are the same size and shape, so they are congruent. So now it's time to jump into some 3D shapes and naming them. So here's some more vocabulary. We're going to start with prisms. A prism is a solid, so that means another way of saying that is that this is 3-dimensional. And it's a solid with 2 congruent parallel bases and faces that are parallelograms. So let's go through and deconstruct that definition a little bit using this cube. And cubes are a type of prism. We'll talk about why they're special in a second. So 2 congruent parallel bases. So on this cube, let's just start with this one. We'll call this base A, and we'll call this B. This face, this bottom face here, is a square, and this top face is a square. So they are congruent. Now, if I look at them, will they ever intersect? If I extend these faces out, if I make these 2 square faces, if I start expanding them, making them bigger and bigger, or I start extending their lines out, are they ever going to intersect? And if you look at them, they won't. They're like train tracks. If I were to start extending the line out here and this line out here, they're never going to intersect. They're running parallel. Okay? So they are parallel bases, and they are squares, and squares are a type of parallelogram. So that's what we're talking about when we're talking about prisms. Here's another kind of prism. This is a rectangular prism. Now, it's a rectangular prism because at least one of its faces is a rectangle. A cube is a special kind of prism because all of its faces, all of them are squares. Now, a rectangular prism can have some square faces, like this one does, here and here, but some of its other faces are not. So then we call it a rectangular prism. Now let's take a look at pyramids. Pyramids are similar to prisms, but there's a major difference, and you've probably already seen it with your eyes. Pyramids are a solid, again, that means 3D, with a base that is a polygon. The edges of the base are joined to a point above the base. So let's take a look at this one. We've got a base here. It's a rectangle. A rectangle is a polygon. Now the edges of this base, they come up and they all join to this one point up above the base, or vertex. Remember, when we have edges that come together, it's a vertex. And this is a special vertex on a pyramid because all of the edges come to that point. Instead of having another rectangle up here, like on a prism, they come to a point. Now, pyramids, just like prisms, are named by their bases. This pyramid is a rectangular pyramid because its base is a rectangle. This pyramid is a triangular pyramid because its base is a triangle and its in fact all of its sides end up being triangles. Now on this pyramid it has a rectangular base, but these other faces are triangles. So what you want to remember is that pyramids and prisms are named by their base. So a rectangular pyramid has a rectangular base. A triangular pyramid has a triangular base. All right. So here's the last screen. I want you to pause the video and name each one of these objects. Give it a name. You may need to rewind the video again to remind yourself of some of the names we've looked at, but give them a name and then we'll come back and we'll see how you did. So pause the video and try it. All right, so this first one, that's a cube. It's a prism that has squares for all of its faces. Squares for all of its faces. And then over here we've got a rectangular prism. Rectangular prism has some rectangles for faces. And a rectangular prism has rectangle faces, and this one actually has two square faces as well. Then down here we've got a square pyramid. It's a pyramid that has a base that's a square, and here you can see what I was talking about. All pyramids have some faces that are triangles, but this one all has a base that is a square. And then the last object here is a triangular prism. Threw that one at you a little bit, but it has a face that is a triangle, so we call it a triangular prism. Its other faces here are rectangles, but it is a triangular prism. Don't forget, if you need to, if you got any questions right now, you can go back and rewind the video and watch it again. I encourage you to do that because there was a lot of vocabulary. And if you have questions, make sure to ask them in class. See you next time.